So in this final section, we're going to talk about graphing a rational function. We're going to use the information that we've gathered over the past few videos to graph these things, along with some information that we already know how to get. So we can find the y-intercept. We can find the x-intercepts when the function is equal to 0 by setting the numerator equal to 0. We can identify vertical asymptotes, and we can graph them. We can identify if there's horizontal or slant asymptotes, and then we can graph those. We can determine where the function might cross these horizontal or slant asymptotes. We can test for symmetry. And then we can plot some points on these particular intervals. So just a few examples of these. Say we want to graph the function f of x was x plus 3 over x minus 2. First of all, the y-intercept when x equals 0 is going to be equal to negative 3/2. And so we know we have a point right here at 0 and negative 3/2, or negative 1.5. We can also find the zeros of the function by setting the numerator equal to 0. This will be the point where it crosses the x-axis. When y is equal to 0, that will give us x equals negative 3. So here's our x-intercept. Now, we have a vertical asymptote at x equals 2. Whatever makes the denominator 0. So at x equals 2, we want to draw our dotted line here for our asymptote. We have a horizontal asymptote. These two powers are the same. And so we have a horizontal asymptote at y equals 1. So as we go further and further out, this thing is going to not cross y equals 1. This is x equals 2. And so now, to get an idea of what this function looks like, from what we know, we want to determine what's going to happen as x approaches the vertical asymptote from the left and right. So as x approaches 2 from the left, well, these are values smaller than 2. So we're going to take a value smaller than 2, plug it into our function. X plus 3 over x minus 2. If we plug in a number that's smaller than 2, so 1.9, we get 4.9 divided by negative 0.1. So we can see that this is negative 49, which means this value, as we approach 2 from the left, or the function, is going to approach negative infinity. From the right, we do the same thing, just with a value greater than 2, so 2.1. 2.1 plus 3 over 2.1 minus 2, 5.1 over 0.1, which is just positive 51. So from the right, this function approaches positive infinity. And so if we use our function values and the asymptotes are drawn, we can see that our function should look something like this.